Okay, so this is a Medium article that describes how to apply multimodal generative AI to scenarios in banking. The specific problem statement that we will take is of application performance analysis, the specific issue of memory leak detection. In a fast-paced environment like BankNext, there are more than 100 microservices that need to be deployed. Our performance testing team has a huge challenge on hand. They have to test all these applications, and each of these applications will have many more endpoints in there, and each of these endpoints need to be tested for performance behavior and potential degradations. Now, given the kind of pressure that they go through in the heat of the moment, it is entirely possible that they inadvertently miss out on certain metrics that point to a degradation of the application, a memory leak, but it gets overlooked. When this happens, memory leaks creep into the production deliverables, and it has a serious knock-on effect on the pace and the quality of deliverables. This causes serious production issues, and business quickly loses confidence in the production deliverables. These are the kind of problems that we face on a day-to-day basis, and these are some things that we want to address with a solution that is practical and also manageable. Typically, the way a production a performance testing team works is every application is subjected to a rigorous performance testing procedure. Metrics typically taken from Grafana are evaluated, and the PT team diligently looks at these statistics. Heap memory graphs are generally the ones that are looked at to find if there are any potential performance issues like memory leaks. Now, the PT team has to manually examine these volumes of such statistics. This process is laborious and also it is error prone. In such a scenario, warning statistics that point to potential memory leaks can get overlooked despite diligent work from the performance testing teams. It is possible that this overlooking of important statistics may happen. When that happens, production environment suffers serious performance degradation issue, and that causes a lot of problems with business, and also it causes monetary losses. Is there a way to handle this? Can generative AI help us in this regard? That's what we will look at from moving forward. At first, let's look at this architecture diagram that describes the various components in this approach, in this solution approach. We have a Spring Boot application, a standard Spring Boot application which uses LangChain4j. LangChain4j helps us in orchestrating the connections and interactions to our AI engine. Our AI engine is composed of two main components. One is a vector DB, which is used for similarity searches, and the other is a local LLM server. In our case, we are using Ollama. Another important factor here is this particular model that we are using. This is llava, which is a multimodal vision capable model. That means it is able to understand text as well as image and able to interpret what is happening in that particular image. With this combination, we are able to understand when we provide graph like this. These graphs come from as outputs from our performance testings. When we provide graph like this, we can understand what is happening in this graph, and thus we will be able to, our AI engine will be able to answer the question specific to what the user has asked. In this case, the question specific to performance degradation and memory leaks. We will move further. This is the GitHub location where this application is located. You can clone this application and build it and run it on your local. This local LLM setup that we have talked about is entirely hosted on can be entirely hosted on your local machine without any need to reach out to external sources, and it can work without internet as well. The other components that we need in the solution are the ones that we talked of. This is a language model which is llava v1.6. This is the one that we have chosen for our operations. Ollama, LangChain 4j, embedding models. These are standard components for our AI engine. Another important aspect is Docker runtime. The Docker runtime that you need a Docker runtime setup. The one that I'm using, I have described it here, and you can utilize this same setup. It requires two things. One is Oracle VirtualBox, like this, the one that I have here, and it also requires a Docker desktop, like this, the one that I have here. And once you have that, okay, the most important criteria, one of the most important criteria is the capacity of the hardware that you're running this application on. If you're using a local machine, you have to be sure that it has a configuration that is much higher than a 16 GB RAM, 10 GB storage, and 4 cores. My local machine has this configuration, but I still and I've noticed that it takes a long time for this processing of the workload to happen. The other option that I have is to switch over to the cloud resources, and I will show it to you in the demo how it can be done easily by simply using a query parameter. We will now look at the workflow, how the system design flows. We said that the solution utilizes vision capabilities of our multimodal LLMs. In this case, we have chosen the llava 1.6 model. These are the graphs and matrix that have come out from our performance testing. Let's allow it to load. Okay, it's actually available here. This is loaded here. So these are the graphs that have come out from our performance testing results. This one here specifically shows that how memory is getting consumed. This particular line graph shows it continuously increases, and there is no significant drop in the memory. This is typically indicative of a classic memory leak, because memory is consumed but not released to the system. The other example is of this memory utilization. This shows memory being utilized but also dropped periodically. This is a sawtooth pattern which indicates a well-behaved application. That means memory that is consumed is also returned back to the system, and that's why we will not face a memory leak situation. We will move forward now. What we feed into the AI engine, in addition to the image or the picture, is also a system message and a user prompt. In our case, this is a system prompt that we will be feeding in. You are an expert performance tester. This picture, that means this graph that we are sending it, shows a graph of a JVM memory utilized. A well-behaved application shows graph patterns with long and sharp increases in consumption and then long and sharp decrease. If the utilized memory graph shows continuously increasing without dropping sharply, then this indicates a memory leak problem, and memory leak problem exists. So what we are basically doing is we are giving it the context, we're giving it a role, and we're also telling it what in our understanding, what in our discretion is a memory leak, so that it can make its decision based on this context and not just on any random criteria. We're also telling it asking it a specific question after this. Based on the provided graph, please state in your response if the possibility of memory leak problem exists or not. So basically we want our AI engine to tell us whether there is memory leak or not based on these graphs that we have provided. These are the graphs that we just looked at. This is the graph that we will be providing. Now the input to our AI engine will be a combination of the system message, the user prompt, and the image link. The combination of our LLM server Ollama and the vision capable llava model, and we are able to analyze the picture that we have provided to the AI engine. The llava model has the capability to interpret the graph lines in this picture and understand how this memory is getting utilized. With this information, our AI engine is now capable of answering the questions asked by the user with a reasonable degree of accuracy. This is the curl that we will use to test this application, and so before that we will run the application. You can clone the application on your local, and the standard way of building it is this mvn clean install. So this is a standard Maven based Spring Boot application. It has a POM with the various dependencies that are required. So this will download all the dependencies that we need, and we'll go ahead with the build is now complete, and I will now start this application with a simple with the regular java -jar command. The application is now started. So now the application is started, we will launch our endpoint and test the output of the AI. This is the curl that we can use to test, and I have it here in Insomnia. So I'm going to run it for this image here. This is the same prompt as we talked of, and this image is a graph that continually increases, which means that the memory is continuously consumed and not released. That means there is a memory leak exists. We will see what our AI responds to. Yes, so our AI basically says that yes, there is a memory leak. So it has given us the correct response. What if for the other case, this image here is of this one. So this one is a application that actually releases memory, and hence it goes down. So for this case, we should see that there is no memory leak. Yes, and we have also got the correct response here, that there is no memory leak here. Let's go back to our flow. So we have got this correct responses from our AI, and these are basically the screenshots of the earlier runs, which basically have the same responses and output. So now that we have executed this application and got the result, let's look at what's involved in actually setting up this application. We looked at the main components earlier, the vector DB, the Ollama server, and the llava model. This section here, application setup, in this document is from an earlier article, basically gives complete setup details of how you can create this AI application setup on your local machine. You can follow these steps here, and you can have the entire setup done on your local machine. In addition to this setup, you will also need the llava model on your local machine. For that, you can run these standard Ollama commands. In this case, I am downloading and incorporating this llava model. Depending on the capacity of your machine that you're working on, you can choose one of these models. The smallest model is this one, but it is also less accurate. There is another one. This is the recommended one. You can use this one depending on the capacity of your machine. This is the one that is more accurate, but it also is more heavy on your resources. So make a decision which one you want to go for, and then move forward with it. Once this model is incorporated into your Ollama server, you will need to provide the name in the application.properties. In the application.properties, you will have to just provide the exact name that you have incorporated here. For example, this is my application properties, and here I have given the name of the LLM model that to be used is llava. Okay, let's move forward now. Modes of operation. So like we said, this workload requires heavy processing, and that's why your machine has to have that much configuration. So you have two options now. Either if your machine has that kind of configuration and you're able to run it, then you can just run it on your local machine, or you can switch to resources on the cloud, and this can be done very easily. First case, if your machine is capable enough to handle, you just have to set this query parameter to execute on local machine Y, just like we have here in your endpoint. If you want to run it on your local machine, you will be simply setting this to Y. Now the default is a no, because my machine is not capable enough to handle this kind of workload, and hence this workload goes to, if I leave it blank, this workload directly goes to the cloud resource. And the way you will set up the redirection on the cloud resources in these three simple steps. You will log in or sign up for this particular resource, auth.install.tech, and you will create tokens using this particular resource. Once you get the token, you will pass the token into your application properties, just like here, the way I have passed it. Cloud.resource token, and what your specific token you will be passing in here, and with this you will be able to run your workloads directly onto the cloud. You just have to ensure that this query parameter execute on local machine is blank. That means it will send it to the cloud. Now that we have looked into the execution and the entire setup, let's go into the final conclusions. So what have we achieved thus far? On the positive side, we have seen that BankNext has successfully applied this multimodal vision capable model llava, and executed this use case with multimodal GenAI. With this, we have been able to drastically reduce occurrences of memory leak oversight. This has also tremendously helped lower the performance testers' workload. It has significantly improved the production and deployment success rates, and with this we have created a flexible solution that can be extended to multiple scenarios. So just like memory leak, we can extend this to, say, CPU utilization overload or database utilization overload, or a completely different kind of scenario like architecture diagrams. You can pass the architecture diagrams and get information on what is lacking in that architecture diagram, or you can compare two architecture diagrams. Once you find what is lacking in the architecture diagram, then you can take the necessary steps to improve that diagram. So there are multiple scenarios in banking that you can apply this flexible solution to. What are the negatives? As we saw, It requires massive computing GPU resources. On a CPU type machines, it takes a very long time to execute. The latency is high. Also, you will notice that variations occur in the responses of the content with every run. There are times where you can also see unexpected and inaccurate responses that come. And that's why a manual review is always a must in this kind of generative AI solutions. So what have we achieved? What is our accomplishment? Multimodal generative AI solution provided a high level of performance confidence in applications deployed to production. And it has massively lowered the operational cost while maintaining an acceptable level of accuracy. So with this, we have got a tremendous improvement in our execution of performance analysis, and a huge confidence in the way the outputs and the applications are deployed to production, and all this by reducing the load on our performance testing teams. This is a huge improvement. With this, we'll conclude this discussion. Thank you for your time.